In today's lesson, we'll be learning about midpoints and medians in triangles. A midpoint is the point that divides a line segment into two equal segments. This would be considered a line segment, while this would be its midpoint. How do we know it's the midpoint? Well, you can indicate that with these symbols. A median is the line segment joining a vertex of a triangle to the midpoint of the opposite side. I'm going to construct a midpoint at the base of this triangle. Again, I'm going to indicate that with these symbols. A median connects the midpoint to the vertex on the opposite side. Therefore, this blue line would be considered the median. In this triangle, I'm going to be constructing a midpoint over here and another midpoint over there. I can indicate that with these symbols. Next, I'm going to be connecting these two midpoints with a straight line. I'm going to be using this diagram for the next few examples. I want to know if there's any relationships in this triangle. Take a close look at this. That line segment happens to be 3 units. Meanwhile, the base of the triangle over here, that happens to be 6 units. Take a close look at these numbers. Are they related somehow? It appears as if the length of the base of the triangle is twice the length of this. Therefore, we can conclude that a line segment joining the midpoint of two sides of a triangle is half as long as the third side. In other words, this length is twice as long as this length. Algebraically, I can say that if this has a length of 2x, then this would have a length of x. Take another look at our diagram. Is there a relationship among the angles? Well, it turns out this is 56 degrees. This is also 56 degrees. This is 37 degrees, while this is also 37 degrees. If you recall, this forms an F pattern. This also forms another F pattern. So is it possible that these two lines are parallel? Therefore, we can conclude that a line segment joining the midpoints of two sides of a triangle is parallel to the third side. In other words, this line segment and this line segment are parallel, and we can indicate that with these symbols. Looking back at our diagram, we are going to label the height of this triangle. Now, a height starts at the base of your triangle and connects to the vertex opposite. Something like this. However, this has to be at a 90-degree angle. Could there be some sort of relationship here? Well, if I use a ruler and measure this length, that happens to be 2 units. Meanwhile, if I measure this length, that also is 2 units. Therefore, we can conclude that the height of a triangle formed by joining the midpoint of two sides of a triangle is half the height of the original triangle. In other words, this length over here is going to be equal to this length over here. In this triangle, I'm going to be constructing a midpoint at the base of the triangle. I can indicate that with these symbols. Next, I'm going to be drawing a line from this vertex all the way to this midpoint I just created. This line would be called a median. Using a ruler, I'm going to measure this triangle. I'm going to measure this side, and the median I just constructed. This happens to be 3 units. This is also 3 units. And this would be 4 units. Could there be a relationship between this triangle as well as this triangle? Where you will see. I'm going to start by determining the area of the yellow triangle. Area of a triangle is base times height divided by 2. So 3 times 4 divided by 2, that simplifies to 12 over 2, which becomes 6 units squared. Well, you can do the exact same thing with the green triangle. So base times height over 2, which is the same thing. 3 times 4 divided by 2, which simplifies to 12 over 2, which becomes 6 units squared. As you can see, the area of these two triangles are exactly the same. Therefore, we can conclude that the medians of a triangle bisect its area. In other words, the area of this triangle is going to be exactly the same as the area of that triangle.